All of you can see the screen. All of you can see the screen. Okay. Carbon ions can be stabilized by minus I or minus R effect. Minus I or minus R effect. Minus I we have already seen. What is minus R effect? Minus R effect is electron withdrawing electron withdrawing resonance effect. Electron withdrawing resonance effect. It is shown by the molecules in which atom attached to ring is multiple bonded to more electronegative atoms. Multiple bonded to more electronegative atoms. Multiple bonded to more electronegative atoms. For example, if we have ring and we have NO2 group, so NO2 group is actually like this. Can you see that multiple bonded to more electronegative atom? Can you see that multiple bonded to more electronegative atom? So NO2 CN CN. It is also multiple bonded to more electronegative atom. CHO. It is also multiple bonded to more electronegative atom. Silence readable. Do it fast. आपको ये ध्यान रखना है because there can be so many of examples. You just have to think about this. Attached to the ring is multiple bonded. Atom attached to the ring is multiple bonded to more electronegative atom. Understood? Cations attached to ring. Cations attached to ring also shows minus R effect. NH3 plus shows minus I effect because we know it cannot have resonance. अगर resonance करता है तो it has to form 5 bonds, which is not possible. So NH3 plus shows minus I effect. Understood? Halogens shows minus I effect dominates over plus R effect. Generally, those elements which have lone pair shows plus R effect. But because of high electronegativity, halogen shows minus I effect over plus R effect. Generally, elements having lone pair of electrons or groups having lone pair of electrons shows plus R effect. But halogen shows an exceptional case because of their high electronegativity. They show minus I effect instead of minus R effect. Sorry, plus R effect. Understood? Any doubt in here? I said those atoms which are having lone pair of electrons attached to the ring generally shows plus R effect. They donate electrons to the ring. Only halogens are the exceptions, which because of their high electronegativity shows minus I effect instead of plus R effect. Instead of plus R effect. Okay, Aman. Order. Understood? Okay. So we'll follow it like this. Minus R effect is shown by PR3 plus NO2 CN COCl COH CHO C triple bond C C double bond C minus R effect plus R effect plus R effect plus R effect it donates electrons to the ring. It donates electrons to the ring and increases electron density and increases electron density and increases electron density. It is shown by the atoms having lone pair of electron or negative charge or negative charge. Lone pair of electrons or negative charge. Copy it fast. Done. For example, if you have NH2 attached to the ring, or you have O minus, or you have CH2 minus, or you have OH. Any group which has lone pair of electrons attached to the ring will show plus R effect, will increase electron density on the ring. Increase electron density on the ring. Understood? Order will be NR2, NHR, NH2, OH, OR, and that's it. ये प्लस आर का इफेक्ट हो गया. That was for minus R. Understood? Any doubt in plus R and minus R? For example, we have a ring on which some substituent is present. If it is electron withdrawing group, it will decrease electron density from ortho and para position. Decrease electron density from ortho and para position. Ortho and para position. If you have electron donating group, it will increase electron density at ortho and para position. It will increase electron density at ortho and para position. ठीक है, मेटा पर कोई इफेक्ट नहीं होगा. दिस इज योर मेटा पोजीशन. इस पर कोई इफेक्ट नहीं होता रेजोनेंस का. दिस इज योर मेटा पोजीशन. नो इफेक्ट ऑफ रेजोनेंस. अंडरस्टूड? अंडरस्टूड? रेजोनेंस डिस्टेंस डिपेंडेंट नहीं होता है. रेजोनेंस इज नॉट अ डिस्टेंस डिपेंडेंट इफेक्ट. Resonance is not a distance dependent effect. unlike inductive effect. So why are we reading all this? हम क्यों पढ़ रहे हैं? Because we were on the anions. हम anions पर थे last class में. So we do have to talk about the stability of anions. We do have to talk about the stability of anions. So if we have this Cl, Br, and I, which one is maximum stable? Which one is maximum stable? A, B, C. पहले हम देखेंगे this is anion, so it will be stabilized by minus effects. Anions are stabilized by minus effects. पहले ये देखेंगे, फिर देखेंगे R is dominant over I, minus R will be dominant over I. फिर हम देखेंगे ये वाले ग्रुप्स कौन सा इफेक्ट शो करते हैं, माइनस आई, माइनस आई, माइनस आई. फिर ऑर्डर देखेंगे. वी नो क्लोरीन इज बेटर देन bromine is better than iodine, so this will be maximum stable. Understood? Understood? Any doubt in this? Any doubt in this? I got only one answer. What about others? Which one is more stable? Which one is more stable? Which one is more stable? This will show minus R. This will also show minus R. Minus R is not a distance dependent effect. माइनस आर इज नॉट अ डिस्टेंस डिपेंडेंट इफेक्ट. मतलब ये दोनों तो इक्वलाइज है. इट कैन नॉट डिस्क्रिमिनेट देम और डिफरेंशिएट देम. फिर इसमें आई इफेक्ट देखेंगे. इट विल हैव मोर आई इफेक्ट, लेस आई इफेक्ट, क्योंकि आई इफेक्ट डिस्टेंस डिपेंडेंट इफेक्ट होता है. सो ए इज बेटर देन बी. अंडरस्टूड? Any doubt in this? Which one is more stable? A or B? B. ये लगाएगा माइनस आई इफेक्ट. मेटा पोजिशन जिससे वी कैन हैव ओनली माइनस आई इफेक्ट. ये लगाएगा माइनस आर इफेक्ट. From ortho and para we can have minus R effect, and we know resonance is dominate over inductive effect. So B is greater than A. Understood?
मेटा पे रेजोनेंस नहीं होता.
नहीं, मेटा पर रेजोनेंस का इफेक्ट नहीं होता. इसका जो रेजोनेंस होगा, इट विल डिक्रीज द इलेक्ट्रॉन डेंसिटी एट दिस पोजीशन एंड एट दिस पोजीशन. Where we want, there it won't decrease the electron density.
Okay, sir.
You must have read about the resonance of this. NO2 जब अपना रेजोनेंस करता है तो it creates positive charge at ortho and para position. It does not create positive charge at the meta position. Okay.
Yes, sir.
Yeah. What is the order of stability? Order of stability. All are anions. We'll see their effects only. We will say their effects only. This will show plus H. This will show minus I. This will show plus R. This will be your reference. It will be maximum stable. Which will be maximum stable. So we can say B is better than D is better than A is better than C. Any doubt in this? Any doubt in this? Any doubt in this? What will be the order of stability? Order of stability. D C B A. This will show plus R. This will show plus R. This will show minus I. This will show minus R. Plus R of NH2 is better than plus R of OH. Nitrogen is a better donor because of more electronegativity. Sorry, less electronegativity. So maximum stable is D, then C, then B, and then A. Any doubt in this? Any doubt in this? Which one is more stable? A or B? Which one is more stable? This is sp hybridized. This is sp2 hybridized. This is more electronegative. This is less electronegative. So B will be better than A. Very good. What is the order of stability? Order of stability. Order of stability. This is resonance stabilized. This is aromatic. This is anti-aromatic. Which one is more stable? Which one is more stable? यहाँ पर आई इफेक्ट नहीं देखना है. इफ इट इज एडजेसेंट तो बैक बॉन्डिंग लगेगी. Cl has vacant d orbital. Cl has vacant d orbitals. So B is better. Similarly, sulfur is better. Understood? Any doubt in this? Write on free radicals. Free radicals. They are formed by the homolytic cleavage of a bond. They are formed by the homolytic cleavage of a bond. Stability of free radical is same as the stability of carbocation. sp2 hybridized planar species. sp2 hybridized planar species. Understood? That means 3 degrees better than 2 degrees better than 1 degree is better than methyl free radical better than vinyl free radical better than phenyl free radical. Allyl free radical better than benzyl free radical. Understood? सब रीजन सेम है. हाइपर कॉन्जुगेशन एंड प्लस आई इफेक्ट और रेजोनेंस. ठीक है, यहाँ पर आ जाएगा रेजोनेंस. यहाँ पर आ जाएगा हाइपर कॉन्जुगेशन एंड प्लस आई इफेक्ट. These are unstable ions. Understood? लेकिन क्वेश्चन पूछने का तरीका थोड़ा सा अलग है. How do they ask question on this? That is slightly different. Bond energy of A and B will be A greater than B, B greater than A equal B. इसका अगर क्वेश्चन आता है, it can come in this way. Bond energy, that is the energy required to break the bond. 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 Energy required to break the bond is called bond energy. Yes. कैसे करेंगे? Energy required to break the bond. This will be unstable. It will give unstable free radical. So more energy will be required. More energy will be required. It will give stable free radical. So less energy will be required. Okay. So A will require more energy than B. A will require more energy than B. Understood? Understood? Copy it fast.
सर ये सवाल एसिडिटी में पूछ सकते हैं?
नहीं, एसिडिटी में आपको H प्लस मिलता है और यहाँ पर तो फ्री रेडिकल मिल रहा है ना.
ओके सर.
ये पूछ रहे हो ना आप?
हाँ सर.
या फिर आप बोल रहे हो कि ये कंपाउंड देके दे कैन आस्क द एसिडिटी और नॉट?
हाँ वही पूछ रहा हूँ.
अगर ये कंपाउंड देके बोल रहे हैं कि एसिडिटी बताओ, देन फ्री रेडिकल कंसेप्ट तो खत्म हो जाएगा. Then there will be B, there will be A. Make both the anions. Tell me which anion is more stable.
ए.
A, मतलब ये ज्यादा एसिडिक हो गया. अंडरस्टूड?
यस सर.
तो उसमें फ्री रेडिकल भी खत्म हो जाएगा, फिर फ्री रेडिकल की बात नहीं हो रही है. एसिडिटी मींस यू आर रिमूविंग H प्लस. ओके, एंड बॉन्ड ब्रेकिंग मींस फ्री रेडिकल.
हाँ सर समझ गए.
ओ श्योर, एक और देखते हैं. ठीक. ऑर्डर ऑफ बॉन्ड एनर्जी. Order of bond energy. Order of bond energy. This will be vinyl. This will be 2 degree. This will be 3 degree. 2 degree with allyl. This will be 2 degree. This will be 3 degree with allyl. Any doubt in naming? Any doubt in naming? साहिल एक आया भाई. Any doubt in naming? So C will require minimum energy. Then B. Then E. Then D. And then A. Any problem to anyone in this? Any problem to anyone in this? Hanuman, you didn't do it. Aman. अमन, आपकी नेमिंग समझ में आ रही है? अमन, नेमिंग समझ में आ रही है? Are you getting these names?
हाँ सर, नेमिंग समझ में आ रही है.
That's it then. What we have said, unstable free radical will require more energy क्योंकि वो unstable है. It do not want to get breakdown. So unstable will require more energy. Stable will require lesser energy. उतना ही है. 3 degree allyl will be maximum stable. Then 2 degree allyl will be stable. Then 3 degree will be stable. Then 2 degree will be stable. And minimum stable will be vinyl free radical. अगर आपको नेमिंग समझ में आ जाती है तो
सर आप एलाइल वाला पार्ट एक्सप्लेन कर सकते हैं जो ऑपोजिट है एक दूसरे के.
So you are not getting it how they are 2 degree allyl, or you want to know कि how they are stable. आपको ये समझ में नहीं आ रहा वो
how
allyl?
they are stable.
How they are stable. Allyls have resonance. I told you this in the resonance also. They have resonance. ये bond free radical form में break करेगा. It will move to here. They are resonance stabilized. Allyls and benzyls are resonance stabilized.
Yes sir, yes sir. So
Okay.
I was confused
Now,
between allyl and aryl.
aryl is completely a different thing. Ring will be there.
Yes sir. Yes, understood.
Okay. You can get confused between vinyl and allyl. विनाइल एलाइल में कंफ्यूजन हो सकता है, लेकिन अराइल और एलाइल में कोई कंफ्यूजन नहीं हो सकता। अराइल के अंदर देयर इज एन AR स्टैंड्स फॉर एरोमेटिक, वहां पर रिंग होगी तभी अराइल हो सकता है। विनाइल और एलाइल में कंफ्यूजन हो सकता है। विनाइल के अंदर फ्री रेडिकल ऑन द डबल बॉन्ड एंड अलाइल के अंदर फ्री रेडिकल एडजेसेंट टू डबल बॉन्ड। अंडरस्टूड?
सर आपने भी क्या बोला था, रिपीट करें।
मैंने बोला कि इन केस ऑफ विनाइल फ्री रेडिकल इज ऑन द डबल बॉन्ड, in case of allyl free radical is adjacent to double bond. That's what it says. Okay, Aman.
Yes, sir, understood.
Write down carbenes. Carbon having sextet of electron. Carbon having sextet of electron. This intermediate is present in two reactions: Riemer-Tiemann reaction Riemer-Tiemann reaction and carbylamine reaction. And carbylamine reaction. Riemer-Tiemann reaction and carbylamine reaction. ठीक है? So if I write CH2, so these electrons are not bonded. Unshared electron. Unshared electron. But ये lone pair नहीं है. These are unshared electrons, but they are not lone pair. Lone pair बनता है after the formation of octet. Octet complete होने के बाद whatever you have is called lone pair. This is not the lone pair. This is the unshared electrons looking for bonding. ये किसी से bond करना चाहते हैं. Understood? इसको पहले लिख लेते हैं. These two electrons, I don't. These two electrons these two electrons can be present together as paired electron or these two electrons can be present in two different p orbitals. Copy it fast. मतलब अगर हम CH2 देखते हैं, if we see CH2, so carbon was 2s2 2p2 in the ground state. In excited state, this was the ground state. This was the ground state. But whenever it wants to form bonds, it go to excited state. Excited state में क्या होगा? This electron will move here. Now this is excited state. Understood? Now in this state, it is forming two bonds with hydrogen with hydrogen. Now these are the two electrons we are talking about. The understood? Now these electrons can be paired up. ये दोनों इलेक्ट्रॉन्स पेयर अप हो सकते हैं. ये दोनों इलेक्ट्रॉन्स पेयर अप हो सकते हैं. Or these two electrons can be present separately as they are already present. So these can be the two cases with the electrons. Understood? इसमें एक ये जो है हाइड्रोजन है. You should not get confused. This is coming from hydrogen. This is coming from hydrogen. ठीक है, इसके अंदर भी this bond is formed by hydrogen. Hydrogen. Understood? In this case, its hybridization will be sp2. In this case, its hybridization will be sp. Two different hybridization are there for carbenes. Two different hybridization are there for carbenes. Any doubt till here? Any doubt till here? No. This is called singlet carbene. Singlet carbene. Singlet carbene. And this is called triplet carbene. सिंगलेट कार्बीन एंड ट्रिपलेट कार्बीन. मतलब ट्रिपलेट कार्बीन की हाइब्रिडाइजेशन sp है, सिंगलेट कार्बीन की हाइब्रिडाइजेशन sp2 है. अंडरस्टूड? अंडरस्टूड? होता क्या है? देयर इज अ टर्म कॉल्ड स्पिन मल्टीप्लिसिटी. Multiplicity, which is given by the formula 2 into total spin plus 1. 2 into total spin plus 1. In this case, all electrons are paired. All electrons are paired. Net spin is 0. So it is 2 into 0 plus 1. That is 1. Hence it is called singlet. Here, two electrons are unpaired. Both have plus half spin. So it becomes 2 into 1 plus 1. That is 3. Hence it is called triplet carbene. Understood? Understood?
Yes, sir.
All of you understood this? Kinmin, what you want me to explain again? Which part? In carbene, there are two extra electrons and two bonds. Spin multiplicity is given by the formula 2s plus 1, where s is the total spin. S is the total spin. We know that this has plus half spin, this has minus half spin. So here all the electrons are paired, so total spin will be 0. Plus half minus half, plus half minus half, plus half minus half. If it is 0, then it will be 2 into 0 plus 1. It will come out to be 1. 1 की वजह से इसको singlet बोलते हैं. If we go here, then this plus half minus half 0, plus half minus half 0. But we have such two electrons, plus half and plus half. Plus half and plus half will become 1. So 2 into 1 plus 1 is 3. Hence it is triplet carbene. ठीक है, जस्ट मैंने बताया कि नेम इसका कहां से आया है. Why do we have singlet and triplet? More important is hybridization.
सर
Yes.
सर हमें कैसे पता लगेगा कि वो जो स्पिन है प्लस में है या माइनस में है?
No, when you fill up the electron, you have to fill first the plus half and then the minus half. पहले आप हुंड रूल के हिसाब से क्या करते हो? पहले आप सबको प्लस प्लस से फिल अप करते हो एंड देन यू गो फॉर द माइनस वन.
ओके सर.
Okay. So if these are those p orbitals, if both the electrons are present together, and if both the electrons are present like this, then which one is singlet, which one is triplet, which one is singlet, which one is triplet? This is singlet, this is triplet. Understood? Understood?
Yes, sir.
ठीक. दूसरा लेते हैं. Write down reaction mechanism. Reaction mechanism. reaction mechanism. Okay, so in any organic reaction, there are reactant which is giving product. ठीक है, ये तो किसी भी सिंपल रिएक्शन के अंदर होता है. Now in organic reaction there is a substrate. There is a reagent. There is a solvent. And then we have product. Substrate, reagent, solvent, product. Understood? Now your substrate will be name of our chapters like alkane, alkene, alkyne, alcohol, phenol, aldehydes, ketones, carboxylic acid, etc. जिसके ऊपर हमें रिएक्शन करनी है, that will be our substrate. Second is reagent. Reagents can be electrophiles or nucleophiles. Reagents can be electrophiles or nucleophiles. Reagents can be electrophiles or nucleophiles. What do we mean by electrophiles? Electrophiles क्या होगा?
इलेक्ट्रॉन डेफिशिएंट.
Deficient. Electron loving species. Electron loving species जो इलेक्ट्रॉन के पास जाते हैं. They must be electron deficient. How will you come to know that they are electron deficient? आपको कैसे पता चलेगा उन्हें देख के कि वो इलेक्ट्रॉन डिफिशिएंट हैं?
पॉजिटिव चार्ज होगा.
पॉजिटिव चार्ज होगा. और उनका ऑक्टेट कंप्लीट नहीं होगा. वेरी गुड हेबा. So electrophiles can be neutral as well, but mostly they are positively charged species. Positively charged species. आपको क्या लगता है कि वो अटैक बियर करेंगे और दे विल अटैक? They will bear the attack or they will attack. मतलब वो खुद जाके अटैक करेंगे या उन पर आके कोई अटैक करेगा. They will bear the attack. Electrophiles will definitely have a vacant orbital. ठीक है, आपको एरो इस तरह से बनाना है that electrons are coming towards electrophile. You do not have to push electrons from electrophile to someone. हमेशा electrons electrophiles की तरफ आने चाहिए. Electrophiles are having vacant orbital and they always bear the attack. झेलेंगे अटैक. Understood? For example, इलेक्ट्रोफाइल्स में आ सकता है NO2 प्लस, Cl प्लस, कोई भी हेलोजन प्लस, एनी एल्काइल प्लस, RCO plus. These all can be the electrophiles. Hydrogen plus. न्यूट्रल के अंदर SO3 vacant D, BF3, AlCl3, ZnCl2. They can be the electrophiles, neutral electrophiles. Neutral electrophiles. Understood? Understood?
Yes, sir.
Just wait for 1 minute. For example, we have ethene. Now, ethene has pi electrons. Ethene has pi electrons. Pi electrons are loosely held, loosely pegged because of sidewise overlapping, and they have some electrophile. Electrophile को ऐसे show करते हैं. Then these pi electrons can attack on that. उससे क्या होगा? Now, if any of the carbon want to attack on this, then it has to become negative. So one of them will become negative, one of them will become positive, negative will attack on the electrophile, and positive will remain as it is. This is how we have a reaction with electrophiles. This is how we have a reaction with electrophiles.
So please explain again.
In these two bonds, one of the bond was pi bond. In pi bond, electrons are loosely held, loosely pegged. Why they are loosely pegged? Because of sidewise overlapping. So they will act as electron-rich species. They will act as electron-rich species. So this will attack on the electrophile. Why? Because they are deficient. If any one of the carbon want to attack on positive, it has to become negative. So first they will become like this. They will break their bond and become like this. Now then this negative will attack on the electrophile. This negative will get neutralized and you will be left with a positive charge. ठीक है, होगा इस तरह से, but we have to show in the upper manner. जैसे हमने ये दिखाया, this is how we have to show. Actually, it is happening like this. The second one. Understood? Understood?
Yes, sir.
Sure. एक और देखते हैं. For example, we are doing the same thing on benzene. Benzene also has 5 electrons, and let the electrophile be Cl plus. What will happen? This will attack on this. But what I said, to attack on positive, it has to become negative. So one of them will become negative, and that will attack on the Cl. Other will become positive. It will be like this. Understood? Understood? कॉपी कर लो इसको जल्दी से. Copy it fast. What are nucleophiles? Nucleophiles क्या होते हैं? Nucleophiles are nucleus loving species. Nucleophiles are nucleus loving species. Nucleus पर होता है positive charge. So they are positive loving species. So if they are positive loving species, they will definitely be negatively charged species. They will definitely be negatively charged species. Understood? What do we mean by this? They are negatively charged species. What do we mean by this? They are negatively charged species.
एक्स्ट्रा इलेक्ट्रॉन होंगे.
Very good. They are electron rich species. Electron rich species. They can be neutral as well. So they are neutral. They are nucleophile. How will you come to know? By seeing a neutral nucleophile.
They should have a lone pair.
They will be having a lone pair. They should have at least one lone pair. आई एम मेकिंग दिस क्लियर अगेन कि कार्बीन्स इलेक्ट्रोफाइल्स हैं, कार्बीन्स न्यूक्लियोफाइल नहीं है। एग्जाम्पल CH3 माइनस, NH2 माइनस, OH माइनस, F माइनस, Cl माइनस, Br माइनस, I माइनस, SH minus, PH2 minus. So many nucleophiles we can have. Understood? Any doubt in this? अच्छा, ये तो बेयर्ड न्यूक्लियोफाइल हो गए। बेयर्ड मीन्स जिसके पास नेगेटिव चार्ज है। देयर कैन बी कवर्ड न्यूक्लियोफाइल। कवर्ड न्यूक्लियोफाइल, कवर्ड न्यूक्लियोफाइल, बेयर्ड न्यूक्लियोफाइल, कवर्ड न्यूक्लियोफाइल। कवर्ड मतलब न्यूट्रल, बेयर्ड मतलब नेकेड न्यूक्लियोफाइल। अंडरस्टूड? ठीक है, तो which is the best nucleophile among them? It is the best nucleophile among them. A. Shantanu, we do not want to hold electron. We want to attack those electrons. F तो आसानी से रख लेगा नेगेटिव चार्ज. It is highly electronegative. Why will it donate its pair of electron? और वेद आपने बीच में से उठा लिया यार. या तो इस तरफ रहो, either on the completely left or be on the completely right. बीच में से आप कैसे उठा रहे हो? Across the period, nucleophilicity. Nucleophilicity का मतलब अमन there is a negative charge. Nelia there is a negative charge. Nucleophilicity का मतलब tendency to act as nucleophile. Nucleophilicity का मतलब tendency to act as nucleophile. Across the period, nucleophilicity decreases due to increase in electronegativity. Understood? Ved, और शांतनु, sir, they should not hold the negative charge. Yes, they should not hold the negative charge. They should be unstable with that negative charge. अगर अनस्टेबल होंगे तभी तो वो अटैक करेंगे, स्टेबल होंगे तो लेके बैठ जाएंगे. Why will they attack? We want them to attack. Understood? Along the group, top to bottom, nucleophilicity increases due to increase in polarizability. Due to increase in polarizability. कहाँ पढ़ा था हमने वर्ड? Where we have learned about this word polarizability? केमिकल बॉन्डिंग तो ठीक है, फजान्स रूल के अंदर पढ़ा था. Okay, so more polarizability, more easily they can interact with other thing. More polarizability, more easily they can interact with the other thing. तो नीचे जाते हुए I minus, Br minus, Cl minus, F minus, SH minus is better than OH minus. Understood? What do you think? Paired nucleophiles will be better or covered nucleophiles will be better? What do you think? Paired nucleophiles will be better or covered nucleophiles will be better? Beard. Charged nucleophiles are better than neutral nucleophiles. मतलब water is less than OH minus. Ammonia is less than NH2 minus. CH3O minus is better than CH3OH. Understood? Any doubt in this? Understood? If I take CH3 sub C double bond O minus and CH3O minus, which is a better nucleophile? Which is a better nucleophile? B is better. कैसे? Because A can have resonance. It is resonance stabilized. अगर stabilize हो गया तो it won't attack. Stabilize हो गया तो it won't attack. Understood? Any doubt in this? Okay. Then we have solvent. There can be a polar solvent, dipole moment not equal to 0. There can be a non-polar solvent. Dipole moment equal to 0. Do we know how to check dipole moment? Do we know how to check dipole moment? मतलब अगर CS2 है, CS2 is like this. It is dipole. It is polar or non-polar? Polar or non-polar? More electronegative. Vector get cancelled out. So CS2, CCl4, CCl4. These are mainly all non-polar solvent. Water. Water is polar solvent. Water is polar solvent. Change in bond. I didn't get it, Chinmin. You know what is dipole moment vector? Okay, so if your net vector addition is 0, then it is non-polar. If net vector addition is not 0, then it is polar. Understood? It's all about dipole moment vector. If you know how to check the dipole moment vector, then it can be polar, non-polar. Acetone. Acetone is polar or non-polar? Acetone is polar or non-polar? अगर आपको नहीं भी पता है, most of the students को you can remember these examples because polarity एक बड़ा टॉपिक है, उसको करने में टाइम लगेगा. That too it is from inorganic. Polar or non-polar? Polar. शांतनु नॉन पोलर कैसे हुआ यार? ये लीनियर थोड़ी है। शांतनु, इट्स नॉट लीनियर। अगर ये लीनियर होता तो आप बोल सकते थे इट इज गेटिंग कैंसल्ड आउट। लीनियर नहीं है, इट इज मूविंग इन वन पर्टिकुलर डायरेक्शन। सर
सर नेट डाइपोल ऊपर की तरफ है ना?
अगेन व्हाट? हाँ, ऊपर की तरफ।
नेट डाइपोल इज अपवर्ड्स।
यस यस यस। So thermocol dissolves in it. No. See, if thermocol is getting dissolved in it, dissolve होने के लिए this is not the only factor. It can be one of the factors. ठीक है, वो थर्मल स्ट्रेंथ पे भी डिपेंड करता है। आप उसकी एक पर्टिकुलर प्रॉपर्टी को चेंज नहीं कर सकते हो। ठीक है, यू कैन से दो ऑर्गेनिक के अंदर ऑर्गेनिक डिसॉल्व होता है, बट यू कैन नॉट से दैट द होल एंड सोल रीजन। देयर कैन बी अदर रीजंस आल्सो। Then there are two important DMF, dimethyl formamide, dimethyl formamide, this will also be non-polar, sorry, polar, and DMSO. DMSO. This is exactly like acetone, just carbon is replaced by sulfur. So this is also polar. Understood? Now, polar solvents can be of two types. Polar solvents can be of two types. Polar protic and polar aprotic. Polar protic and polar aprotic. Polar protic and polar aprotic. Polar protic, polar protic. Polar solvent with hydrogen bonded to phone. Hydrogen bonded to phone. Polar aprotic. Aprotic. Polar solvent without hydrogen bonded to phone. Without hydrogen bonded to phone. जैसे इसमें आ जाएगा वाटर, अल्कोहल, अमोनिया, इसमें आ जाएगा एसीटोन, डीएमएफ, डीएमएसओ। Understood. In polar, sorry, non-polar solvent, we have this order. Nucleophilicity. In polar protic solvent, again we have this order. In polar aprotic solvent, we have different order. Copy it fast. Okay, here it is because of polarizability. Polarizability of anion. Here because of hydration of anion. Here because of charge density of anion. In non-polar solvent, because of the polarizability of anions, I minus is best. In polar protic solvent, ions get solvated by the water molecules. As they get solvated, fluorine will be surrounded by maximum number of water molecules. Hence, its nucleophilicity decreases. In polar aprotic solvent, it is because of the charge density of anion. So this we have to remember. In different solvent, what order do we have and what are the reason behind it? Understood. Understood. Am I audible?
Yes, sir.
Yes, sir.
I know. Types of reactions. Types of reactions. Types of reactions. Substitution reaction. Addition reaction. Elimination reaction. In this, it can be electrophilic substitution reaction, electrophilic substitution reaction, free radical substitution reaction, and nucleophilic substitution reaction. Substitution reaction. Then you have electrophilic addition reaction, electrophilic addition reaction, nucleophilic addition reaction, nucleophilic addition reaction, and free radical addition reaction. Then you have E1, E2, E1CB. These are the type of reactions which we have in the first chapter of 12th class. Okay. Headings we have done in the 11th class also, and this we will do again from the starting. ये 12th क्लास का फर्स्ट चैप्टर के अंदर भी है, 11th क्लास में भी था. It was not given in details, but we have done so much. तो ये हमने पहले बहुत अच्छी तरह कर रखा है. Again we'll do this. Rest we'll do in detail. Done. All of you copied. Can we start now? Can we start now?
Yes, sir.
Electrophilic substitution reaction. तो substitution reaction नहीं लिखना. पहले तो हम substitution reaction देखेंगे. What do we mean by substitution reaction? When an atom is replaced by other atom. Let it be this. Or let it be this. Or let it be this. When one atom is substituted by other atom, it can be electrophile, it can be nucleophile, it can be free radical. When one atom is substituted or replaced by the other atom from the molecule. When one atom is substituted or replaced by other atom from the substrate, then it is called substitution reaction. Then it is called substitution reaction. Right? First one is what? Which substitution reaction is first one? First one is which one? फर्स्ट वन कौन सी सब्स्टिट्यूशन रिएक्शन है?
इलेक्ट्रोफिलिक।
कैसे यार? हाँ तो न्यूक्लियोफाइल रहा है,
न्यूक्लियोफिलिक
न्यूक्लियोफाइल आ रहा है ना, तो इट इज न्यूक्लियोफिलिक सब्स्टिट्यूशन रिएक्शन. सेकंड वन इज व्हाट? सेकंड वन इज व्हाट?
इलेक्ट्रोफिलिक
Electrophilic substitution reaction. And third one is what? Free radical substitution reaction. Right? तो आप देख सकते हो, if nucleophile is coming then nucleophile is going, if electrophile is coming then electrophile is going, if radical is coming then radical is going. Right? So we'll read about electrophilic substitution reaction first. Just wait. Right on electrophilic substitution reaction. Electrophilic substitution reaction. This reaction is given by benzene and substituted benzene. Benzene and substituted benzene. Benzene and substituted benzene. Benzene is an electron rich species. Benzene is an electron rich species. Why benzene is an electron rich species? Why benzene is an electron rich species?
अल्टरनेट डबल बॉन्ड
तो होते रहे डबल बॉन्ड. डबल बॉन्ड से आपको क्या फायदा है? That's not the key word. Because of the presence of pi electrons. Because of the presence of pi electrons. Because of the presence of pi electrons. और बेंजीन के पास क्या है सब्स्टिट्यूट करने के लिए? बेंजीन क्या and it substitutes its hydrogen with the incoming electrophile. Do you think hydrogens are slightly positive charge in benzene? Do you think hydrogens are slightly positive charge in benzene? If yes, then why? Because अगर हाइड्रोजन पॉजिटिव नहीं होंगे, it cannot be replaced by the positive ion.
सर क्योंकि कार्बन हाइड्रोजन से थोड़ा ज्यादा इलेक्ट्रोनेगेटिव है.
And even it is double bonded, so it becomes better.
Yes.
Because the electronegativity of double bonded carbon is more than that of hydrogen. Hence, hydrogens are slightly positively charged. Understood, all of you? So, what should happen? Benzene will react with some electrophile. That electrophile will substitute the hydrogen, and H positive will go out. Understood? Understood. Carbon and hydrogen have very less electronegative difference. Hence, we cannot have this reaction with alkenes. Sorry, alkanes. Alkanes cannot give this reaction. Alkanes cannot give this reaction. ठीक है, neither alkenes nor alkynes. क्योंकि उसके पास pi इलेक्ट्रॉन्स नहीं है. Alkenes and alkynes gives addition reaction instead of substitution. Instead of substitution reaction. Any doubt to anyone in this? Any doubt to anyone in this? Any problem to anyone in this? पढ़ लो एक बार यहाँ तक. पढ़ लो एक बार यहाँ तक.
सर सब्स्टिट्यूटेड बेंजीन
मतलब उसको कुछ लगा होना चाहिए.
ओके सर.
मतलब क्लोरोबेंजीन हो गया, फिनॉल हो गया, एनिलीन हो गया, नाइट्रोबेंजीन हो गया. अंडरस्टूड.
यस सर.
ठीक है, मैकेनिज्म देखते हैं. Mechanism of ESR. Let it be substituted benzene. कुछ भी हो सकता है ये. It reacts with electrophile. It will attack on this. Any doubt in this step? Any doubt in this step?
सर
बोलो.
सर कोई भी डबल बॉन्ड पार्टिसिपेट कर सकता है.
Yes. ये डबल बॉन्ड तो कोई भी डबल बॉन्ड है ना. All double bonds are symmetrical in this case. G का इफेक्ट सारे डबल बॉन्ड पे इक्वल होगा. But benzene want to remain as benzene. Benzene want to remain as benzene. If I say this is a fast step, this is slow step, then what do you mean by slow step? What do we mean by slow step? Slow step से हम क्या समझते हैं? What do we mean by slow step? इससे पहले हमने पढ़ा है कि स्लो
रिवर्सिबल है.
स्टेप. वेरी गुड. और पढ़ा है इससे पहले हमने कभी स्लो स्टेप के बारे में कुछ?
It is rate determining step.
वेरी गुड. हमने केमिकल कंडक्ट में पढ़ा था that slow steps are the important steps of the reactions and yes they are the rate determining steps. स्लो स्टेप को देख के हम रिएक्शन का रेट लिख सकते हैं. वेरी गुड नीलू. वेरी गुड मैम. So this is the rate determining step. मतलब rate of ESR will be directly proportional to your substituted benzene and your electrophile. Understood? ये रिएक्शन तभी होगी, we will have this reaction only when this is a stable cation. If we are not getting a stable cation, this reaction won't take place. ये कहाँ से आ रहा है? It is coming from here. This is how it is depending upon substituted benzene. So rate of reaction is directly proportional to the stability of sigma complex, directly proportional to the electrophile, directly proportional to the substituted benzene. मतलब electron density on benzene इलेक्ट्रॉन डेंसिटी ऑन बेंजीन, इसको बोलते हैं सिग्मा कॉम्प्लेक्स। अंडरस्टूड? There is a hidden step in this called generation of electrophile. ये हम अलग से करते हैं। Generation of electrophile. Generation of electrophile. इलेक्ट्रोफाइल भी जनरेट हमें खुद करना पड़ेगा। Any doubt till here? Order of benzene for ESR. 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 Which benzene you think have more tendency for undergoing ESR? Do you think ESR requires high electron density on ring? Do you think ESR requires high electron density on ring? जितना ज्यादा रिंग पर इलेक्ट्रॉन डेंसिटी होगी उतना इजीली इट कैन अटैक. ESR depends on the electron density on ring. ESR depends upon the electron density on ring. तो यहाँ पर आपको प्लस H मिल रहा है, इधर भी आपको प्लस H मिल रहा है, इधर आपको प्लस H मिल रहा है, and here you are getting plus I. Hyperconjugation dominates over I. यहाँ पर आपको 3 प्लस H मिल रहे हैं, यहाँ पर 2 प्लस H मिल रहे हैं, या 1 प्लस H मिल रहा है. So it will be A, B, D, C. Any doubt in this? Any doubt in this? Any doubt in this? Same question. What will be the order? What will be the order? Aman, Aman, can you pick up?
No, yes, sir.
See, in this mechanism, we are seeing that benzene is attacking on electrophile, right? बेंजीन इज
हाँ सर.
अटैकिंग ऑन इलेक्ट्रोफाइल, तो बेंजीन अगर अटैक कर रहा है तो बेंजीन के ऊपर हाई इलेक्ट्रॉन डेंसिटी होनी चाहिए.
हाँ सर.
So we will look for those substituents which can increase the electron density on ring. तो ये हाइपर कॉन्जुगेशन शो करेगा, ये भी हाइपर कॉन्जुगेशन शो करेगा. दिस विल आल्सो शो हाइपर कॉन्जुगेशन. यहाँ पर +3 +2 +1 एंड देयर इज नो हाइपर कॉन्जुगेशन, इसीलिए ऑर्डर हो गया.
अच्छा सर, मतलब इसका भी जो है हाइपर कॉन्जुगेशन से स्टेबिलिटी रिलेटेड है.
बिल्कुल. अब हम जो भी पढ़ेंगे वो सब कुछ इलेक्ट्रॉनिक इफेक्ट से रिलेटेड होगा, वॉट एवर वी डू.
ओके
ठीक है, या तो वो डायरेक्टली याद करने का होगा और इट विल बी रिलेटेड टू योर बेसिक्स. ठीक है,
ठीक है सर.
अल्टीमेट बेसिक्स आपके वही होंगे जो हमने पढ़ लिए हैं.
यस.
Okay. Now in this case, carbon is a better donor than nitrogen, than oxygen. Plus R, plus R, plus R. ठीक है, ये चीज बार बार आएगी. So if you have any doubt, you can ask. Because अभी 5 मिनट बाद फिर से there can be a question in which this thing is related. भाई चल गई है ना. Done. What will be the order? What will be the order? Plus H, minus R, minus I, plus R. Am I audible?
Yes, sir.
Understood this one?
Yes, sir.
D A C B. D A C B. Any problem to anyone in this one? Right on. Position of substituent, position of electrophile, position of incoming electrophile will be directed by the substituent of ring. Whatever the substituents are present on the ring, they will direct that where the incoming electrophile will come. Then even plus its effect increase electrons. Definitely plus का मतलब है increase और minus का मतलब है decrease. Sahil. Even plus I can increase electron density. बस order है that resonance is better than hypotension is better than I. प्लस लिखा है मतलब वो इंक्रीज ही करेगा, माइनस लिखा है तो डिक्रीज करेगा, बट देयर इज अ ऑर्डर. ठीक है, हम क्या पढ़ रहे हैं? पोजीशन ऑफ द इनकमिंग इलेक्ट्रोफाइल विल बी डायरेक्टेड बाय द सब्स्टिट्यूएंट्स ऑफ द रिंग. जो रिंग पर पहले से सब्स्टिट्यूएंट बैठे हुए हैं दे विल डायरेक्ट. So there can be ortho para directing groups. There can be ortho para directing groups. There can be meta directing groups. There can be ortho para directing groups. There can be meta directing groups. There can be ortho para directing groups. There can be meta directing groups. What do we mean by ortho para directing group? For example, you have benzene and the substituent present is ortho para directing. Then your electrophile will come at ortho position and at para position. Generally. Understood? Understood. मेटा डायरेक्टिंग ग्रुप क्या करेगा? This will be meta directing group. Understood? What are ortho para directing groups? Groups which increases electron density at ortho and para position, true, plus R or plus H. Groups which increases electron density at ortho and para position through plus R or plus H effect. Meta-directing groups which decreases electron density at ortho and para position. Groups which decreases electron density at ortho and para position by minus R or minus H effect. Understood? Understood? कौन से होंगे जो
Yes.
इलेक्ट्रॉन which groups will increase the electron density on ring?
Ortho para direct.
अरे लेकिन how you'll come to know? By seeing it. Atoms having lone pair, negative charge, or carbon having hydrogen. If the atom which is directly attached to the ring, it should have lone pair or negative charge, or if it is carbon, it must have at least one hydrogen. So that hyperconjugation हो पाए. Atom multiple bonded to more electronegative atom, or positively charged, or positively charged. Example: NH2, OH, OCH3, halogens, NO2, CN, CHO, COOH, etc. Understood? Understood? पढ़ लो एक बार इसको. ऑर्थो पैरा डायरेक्टिंग ग्रुप और मेटा डायरेक्टिंग ग्रुप. Done, all of you? Done, all of you? जैसे if you have nitrobenzene and Cl plus is coming, where it will go? First case meta. Second case first case meta. Second case ऑर्थो एंड पैरा,
ऑर्थो या पैरा?
या नहीं बोथ। मैंने प्लस बनाया था यहाँ पर, इफ यू,
हाँ ओके सर।
है ना, प्लस बनाया था। 80% पैरा मिलेगा और 20% ऑर्थो मिलेगा। थर्ड केस it can come anywhere. Understood? मेटा क्यों आया शांतनु लास्ट वाला? When there is no group, then all positions are same. When it is not substituted benzene, then all positions are same. When it is not substituted benzene, then all positions are same. तो कहीं पे भी लग सकता है, लेकिन
सर
अगर आप यस
सर वो 80 और 20 कैसे आया?
इसके बारे में बात करते हैं अभी।
हाँ ओके।
सो इफ आफ्टर दिस यू ऐड शांतनु, अगर इसके बाद अगर आप इस पर Cl प्लस डालोगे, then definitely it will go at meta position, because now your group is meta directed. Understood? All of you understood this? So para isomers are more symmetrical. Para isomers have more symmetrical crystal lattice. Hence they have high melting point. So more stable, इसलिए उनकी परसेंटेज ज्यादा होती है। अंडरस्टूड सनमोहन?
यस सर।
पैरा आइसोमर्स आर मोर सिमेट्रिकल। आप 100 अलाइनमेंट ज्यादा अच्छा होता है, so they have more melting point. If they have more melting point, so they are more stable. If they are more stable, तो उसकी परसेंटेज ज्यादा होती है in most of the cases. I will tell you some of the cases जहां पर ऑर्थो भी मैक्सिमम होगा, but generally this para is better than that of ortho. It is because of their symmetrical crystal lattice. ये word आपको use करना है, अगर स्कूल में कहीं लिखना है तो सिमेट्रिकल क्रिस्टल लैटिस। अंडरस्टूड ऑल ऑफ यू?
यस सर।
ठीक है, तो अभी इतना करते हैं, बाकी नेक्स्ट क्लास में करेंगे। बट आप ये सब कुछ पढ़ो फिर से, देन ओनली यू विल गेट द अदर क्लासेस। सब कुछ लिंकअप होगा, हम आगे जो भी पढ़ने वाले हैं। प्लीज डू रीड दिस अगेन एंड अगेन, तभी पॉसिबल है, नहीं तो याद करना पड़ेगा सारा। ओके, थैंक यू।
सर
यस यस,
सर अगले टेस्ट का पोर्शन क्या है?
सॉल्यूशंस।
ओके सर।